So just similar to the first question, assume that you want to have 100,000 in 2 years' time. The interest rate is 10%. How much do you need to invest now to have 100,000 in 2 years' time if interest is compounded quarterly? Second, if interest is compounded semi-annually. So let's solve this. So when interest is compounded quarterly, n, which is the number of compoundings, this we have got two n. So this n in bracket is just for the number of compounding. So n, which is the number of compounding, is compounded quarterly. So it is four times in a year, meaning you get paid interest 4 times within the year. So now I have to find how much do you have to invest now. So we use the same formula for the present value. Now the only thing that changes with this formula is the interest rate. You have to divide it by the number of compoundings, and the number of periods, which is the time also, you multiply it with the number of compoundings. So in our formula here, it's going to be R divided by N. N in brackets represents number of compoundings. But for simplicity's sake, this N, let me make it as T so that you just make life easy. T is the time here. So R divided by N, the number of compoundings, and the time, you're going to multiply it by the number of compounding. So in this question, our future value, the money which we want to have in 2 years, is 100,000. Then our rate is 10%, and the time is 2 years. So we substitute the values. So we say 100,000, open brackets, 1 plus the rate 10%, so it says 0.1, and divided by the number of compoundings is 4. So 0.1 divided by 4. To the power negative, since it's in 2 years' time, so 2 multiplied by the number of compoundings, 4. So to the power negative 2 times 4. So you put this in parentheses. So always take care of BODMAS so that you get the correct answers. So we always start with the parentheses. So here we're going to first do 0.1 divided by 4. Let's get our calculator. 0.1 divided by 4, we get 0.025. Then add that 0.025 plus 1, we get 1.025. Then here in our exponent, negative 2 times 8, times 4, that is negative 8. Colleagues, are we clear up to this part? Any questions? Okay, I'll assume there are no questions. The next thing we need to do, first we need to find 1.025 to the power negative 8. We get, so to two decimal places, we get 0.82. Hundred thousand multiplied by 0.82, you get 82,000. So if you invest 82,000 now and the interest is compounded quarterly, in 2 years' time, you're going to have 100,000. And as you can see, you have to you save a 1,000. Remember, with here when the interest wasn't compounded, you had to deposit an 83,000. Now here it's like you're saving an 82,000. And the further the years go apart, the lesser you need to invest. Yes. Any questions before we go to the second part of the question? We'll have to find if this interest is compounded semi-annually. Yes. Any questions? Okay, we go to the second part. If the interest is compounded semi-annually. So if it's semi-annually, number of compoundings is twice. So n equals 2. So we just get our formula here. Excuse me. So here it will be negative 2 times 2 for the number of compoundings multiplied by the time. Then here our interest rate divided by 2. Yes. Yes, so we do our tabulations. So we start with the parentheses, the brackets. So 1 divided by 0.1 divided by 0.2. 0.1 divided by 2, that is 0.05. 0.05 plus 1, you get 1.05. So we have 100,000 multiplied by 1.05 to the power. So negative 2 times 2, number of years multiplied by the number of compoundings, you get negative 4. All right, next thing that we need to do, we need to find, so what is 1.05 to the power negative 4? 0.822. Here we'll leave it in 3 decimal places. 0.822 And 100,000 multiplied by 0.822, you get 82,200. So that's how much you need to invest if the interest is compounded semi-annually, that is 2 times in a year. And if you want to have 100,000 in 2 years, this is how much you need to invest: 82,200. Okay, we'll look at number 4, which you can call the final example for today. If you invest 10,000 in your savings account, which has an interest rate of 10%, how much will you have in 3 years' time if interest is compounded quarterly and if the interest is compounded semi-annually? So the same thing. This time now we're trying to calculate the future value. All right, we already have our present value, but we want to find out how much is this 10,000 going to be worth in 3 years' time if our interest is compounded quarterly. So when interest compounded quarterly, the number of compoundings, which is denoted by small letter n, is 4. So all we need to do is just get the future value formula. Right, this n originally it was the number of periods. Now since n also represents the number of compounding, so we just changed it to t. That t just means still telling us the time. So multiply the time by the number of compoundings, and the interest rate you divide it by the number of compoundings. Right. So just remember this: if there's any compounding in the question, just know that the rate you divide by the number of compoundings, and the time you multiply by the number of compoundings. The calculations still stay the same. So in this case, our present value is 10,000, brackets 1 plus. The rate is 10%, so convert it to a decimal 0.1 divided by the number of compoundings, which is 4 to the power. So say the time is 3 years, so 3 times 2, so to the power 3 multiplied by 2. So we apply BODMAS. We start here, 0.1 divided by 4. I think we got an answer earlier on, 0.1 divided by 4. 0.025, yes. Then you add by 1, that would be 1.025. You have 10,000 multiplied by 1.025 to the power 6. 3 times 2 is 6. One 1.025 to the power 6. That's 1 point. So we leave it to 2 decimal places, so that would be 1.16. Right, then we multiply 1.16 by 10,000. Right, you have an 11,600. So if you invest 10,000 and if the interest rate is compounded quarterly, in 3 years' time you have the 11,600. What if the interest is compounded semi-annually? So we do the same thing. The only thing that changes is our n. Our n becomes 2. Oh, so here it had to be to the power 4. Sorry, not 2. Here for compounded uh, quarterly. This is 3 times 4, so it's supposed to be to the power 12. Okay, 1.025 to the power 12, 1.34. $13,400. Yes, so you have 13,400. Sorry about that. Then here semi-annually, so here this is where it would be to the power 6. Our time is 3 years. Number of compoundings is twice since it's semi-annually. So it says 0.1 divided by 2, 0.05. 0.05 plus 1, it's 1.05 to the power 6. Right. So 1.05 to the power 6. We get 1.34. Then 10,000 minus 1.34. You also still get 13,400. Let me just make sure all my calculations are correct here. All right, yes. So maybe due to the rounding off, that's why we've got similar numbers. So if we left the decimals in their natural states, we would get a different number.